Hey everyone! Today we are going to break down a really powerful structural design pattern for all you C# developers out there, the bridge pattern. Seriously, this thing is a secret weapon against rigid, clunky code. It's all about building in flexibility from the get-go, especially when you know things are going to change down the line. So let's see how it's done.
So here's the plan. First, we'll cover the basics. What exactly is the bridge? Then we're going to look at a super common coding trap, something called the class explosion. After that, we'll see how the bridge pattern comes to the rescue, we'll look at the code, and then break down why it works so much better. And finally, I'll give you some key signals to look for so you know when it's time to build a bridge in your own projects.
All right, first things first. Before we can really appreciate what this pattern does for us, we need to get the core principle down. So let's start with the official definition. Okay, this is the heart of it right here. The bridge pattern is all about creating a clean separation between the what and the how. Think of the what as the high-level idea, the abstraction, and the how as the low-level nitty-gritty details, the implementation. When you separate them, you can completely change how something works without the part of your code that's using it ever knowing the difference. It's all about freedom and flexibility.
Okay, that sounds pretty powerful in theory, but it's still a little abstract, right? So what kind of real-world problem does this actually fix? Let's ground this with an example that I'm betting a lot of you have run into before.
And that brings us to a classic coding headache, what's often called the class explosion. This is the perfect showcase of what happens when your abstraction and your implementation are tangled up together. So picture this, you're building software for remote controls. You've got a couple of different devices you need to control, say a TV and a radio. And you also need a couple of different remote styles, maybe a simple, basic remote and an advanced one that has more features, like a mute button. Now, without a solid pattern, your first instinct is probably to just create a specific class for every single combination. You'd have a basic remote TV, an advanced remote TV, a basic remote radio. You see where this is going, right? What happens when marketing wants to add a Blu-ray player or a new smart remote? The number of classes you need to create and maintain just explodes. It gets out of hand fast. And the fallout from this is pretty messy. First, you've got this class explosion. Your code base gets bloated and becomes a nightmare to navigate. Second, your whole system is incredibly rigid. Just adding one new remote type means you might have to create a whole bunch of new classes. And finally, you end up with code duplication all over the place. The same logic for power on or volume up gets copied and pasted everywhere. So, how do we escape this maintenance nightmare? Well, this is exactly where the bridge pattern walks in. It's the elegant solution to these very specific problems. We're back to this core idea, decoupling. We have to break the link between the remote control, our abstraction, and the device, our implementation. And the way we do that is by making a really important mental shift. We move away from thinking in terms of inheritance, and instead we start thinking in terms of composition. This is the fundamental difference, the real game changer. Inheritance locks you into and is a relationship. An advanced remote TV is a very specific, locked-in thing. That creates the rigid structure we're trying to escape. But composition? That gives us a flexible has-a relationship. A remote simply has a device that it controls. And that's the magic trick. Now we can pair any remote with any device, whenever we want. Okay, enough theory. Let's get our hands dirty and see how this actually restructures our code. We're going to check out the after picture, breaking it down into its 4 key components. First up, we've got the implementer. Don't let the fancy name fool you. This is just an interface. It's the contract that defines what our implementations, our devices, need to be able to do. In our example, it's a simple iDevice interface. It's the set of rules that any device we want to control has to follow. Next are the concrete implementers. These are our actual TV and radio classes, but the huge difference now is that they're totally independent. They just implement that iDevice interface we just talked about. They are no longer hardwired to any specific kind of remote. They just exist on their own.
Number 3 is the abstraction itself. This is our high-level remote control class. And here's the beautiful part. This class is completely clueless. It has no idea if it's controlling a TV, a radio, or a spaceship. It doesn't care. All it knows is that it's talking to something that follows the iDevice rules. It operates on the interface, not the concrete class.
And finally, we have our refined abstractions. These are our basic remote and advanced remote classes. They add their own specific features, like a mute button on the advanced remote. But just like their parent class, they can be paired with any device that implements iDevice. You get total flexibility.
And the result of all this? Your client code becomes beautifully simple. You just create a TV object, create an advanced remote object, and then you pass the TV into the remote. That's it. They're composed at runtime. That ugly, rigid, advanced remote TV class, we don't need it anymore. It's gone.
So, let's just take a moment to step back and look at the wins here. Why is this new structure so much better than where we started? The benefits are just crystal clear. We get true decoupling. You can invent a brand new smart TV implementation, and you don't have to touch a single line of your remote control code. You get incredible flexibility. Add a new device? No problem. Add a new remote? Easy. The other side doesn't care. And most importantly, we completely sidestep that class explosion problem from the beginning.
Now, a fair question you might be thinking is, hang on, aren't there other patterns that do this kind of thing? It's easy to get these mixed up, so let's quickly clarify why the bridge is unique and not just another name for something like an adapter or a decorator. They each solve a very different problem.
This table lays it out really nicely. The bridge pattern's one and only job is to separate these two things, the abstraction and the implementation. In contrast, an adapter is all about converting an interface you have into one that you need. A decorator is for adding new features to an object on the fly, and a facade is for simplifying a really complex system. They all have their place, but they're not the same. All right, let's bring this all home with the most practical part. How do you actually spot the need for a bridge in your own code? When should the little alarm bells start ringing?
Here are the 3 big signals to watch for. 1. Use a bridge when you know you need to swap out the how without breaking the what. 2. If you catch yourself about to create a class for every combination of 2 different things, that Cartesian product is a huge red flag. And 3. Use it when you want to hide all the messy details of an implementation behind a nice clean interface. If you see these signs, it's probably time to think about building a bridge. At the end of the day, the bridge pattern is really about foresight. It's about designing for the future and solving problems before they get big and messy. So I'll leave you with this question to think about. As you look at your own projects, where could building a bridge today prevent a massive maintenance headache tomorrow?